This is section 11.3, the parabola. We're first going to begin with identifying the focus and the directrix of a parabola. We do want to remember that the graph of the equation y equal ax squared plus bx plus c is a parabola. That is actually the standard form of the equation of a parabola. And of course, a can't be 0 because then we would not have the quadratic equation. Now, just as a reminder, our parabola opens upward if a is positive and downward if that leading coefficient a is negative. A parabola is the set of all points in a plane that are equidistant from a fixed line called the directrix and a fixed point called the focus. So as you can see, here is our focus. Right here, our axis of symmetry we're getting ready to talk about in a moment. And you can see that is where the vertex is located, and we are opening up or down. And here is our directrix. Okay, the line perpendicular to the directrix and passing through the focus is called the axis of symmetry. And the vertex of the parabola is the point of intersection of the parabola and axis of symmetry. So that's pretty important. Right here, we have our vertex. Okay, that's the intersection of the parabola itself and this axis of symmetry. A point P, x, y is on the parabola if D1 equals D2, where D1 is the distance between the focus and P, and D2 is the perpendicular distance between P and the directrix. So you can see those distances right here, D1 and D2. The distance between the vertex and the focus of a parabola is called the focal length. Let's say that again. The distance between the vertex and the focus. So that would be this distance right here. I'm going to circle it and then I'll take this off. That distance is P. Okay? And that is called the focal length. And of course, we have to have the absolute value because distance is positive. Okay, standard forms of an equation of a parabola with a vertex at the origin. So our axis of symmetry is the y-axis, or our axis of symmetry is the x-axis. How would these equations be presented? X squared equals 4py. We would have an axis of symmetry with the y-axis. So when the x is squared, when our y is squared, we're going to have an axis of symmetry, which is the x-axis. Vertex at the origin. As you can read here, the vertex is at the origin. Now our focus is 0p, so that's going to be on the y-axis. And our focus, when we have an axis of symmetry of the x-axis, we're going to have that focus point on the x-axis. Our directrix is y equal to negative p and x equal to negative p. Axis of symmetry, x equal to 0, and that axis of symmetry, that means x equal to 0 is the equation of the x-axis, and y equal to 0 is the equation of the x-axis. So these parabolas with a vertex at the origin are pretty straightforward. And you can see when p is positive, the parabola opens upward, or it opens to the right. It just depends which axis of symmetry we have. P is less than 0, we will open either down or to the left. And that just depends on the axis of symmetry. Okay? And you can see here the x-axis is the axis of symmetry, and here the y-axis is the axis of symmetry. Okay? So we are really used to writing the equation of a quadratic function with the vertex at the origin in the form of y equals ax squared. That's what we're most comfortable with. The benefit of writing the equation as x squared equals 4py is that we can identify the value of p, and that gives us the distance between the vertex and the focus. So that makes it pretty nice. So we begin with y squared equals 8x. So we know, as you can see here, y squared is 4px, and we have 8x. So it must be that 4p is equal to 8. So p is equal to 2. So our focus is 2, 0, and as you can see, our directrix is x equal to -2. So let's take a look over here. We have our focus here at 2, 0, and then here we have at -2, 0, we have our directrix passing through that point. Okay, so now we can, and that directrix is, of course, x equal to -p, the opposite of p. Okay, and our focus is, of course, p0. So we could just circle this and our directrix. Okay, and here is our focus point. Okay, to determine how wide to graph the parabola, we'll determine the length of the line segment passing through the focus, perpendicular to the axis of symmetry, with endpoints that are actually on the parabola. This line segment is called the latus rectum, and the length of the latus rectum is called the focal diameter, and it's equal to the absolute value of 4p. So, to graph a parabola with a vertex at the origin, we're going to first try this example where we have x squared equals 16y. We're asked to identify the vertex, the focus, and the focal diameter. And that will help us identify the endpoints of the latus rectum and write equations for the directrix and the axis of symmetry. So we have a lot to do here. Let's get started. So we know that x squared equals 16y. So we know that 4py is equal to 16y. So 4p equals 16, and we have p equal to 4. Since we have x squared, we have the y-axis as our axis of symmetry. Let me write that in a different color. We have our axis of symmetry is going to be x equal to 0, since that is the y-axis. Okay, we have the vertex is going to be at the origin We're told that. And then we can go ahead and put that vertex there right now. And then we have the directrix. And that directrix will be, since we are opening up, since P is positive, we will be opening up. I better put just opens. Okay, so our x is squared and our p is positive, so we are going to open up. So if we open up from this origin, as you can see, and we're going to add some points, but if we're here, we know that our directrix is going to be p distance, so 1, 2, 3, 4, and it'll be right here. So that is y equal to -4. So there's our directrix. There's our vertex. Here's our axis of symmetry. So we need the focus, and our focus is going to be 0, 4. We can go ahead and plot that right now. 1, 2, 3, 4. And now we can go ahead and talk about the focal diameter. So that focal diameter is equal to the absolute value of 4p, and that's going to be the absolute value of 16, and it's going to be equal to 16. So the endpoints will be 8, 4, and -8, 4. So 1, 2, 3. So here, and here. Okay, so we do know that we now, and I'll erase what I had drawn before, we were just talking about it opening up. We know that we will come around like this. Okay, and it's really not supposed to be pointy, so we really need to work on, and I do too, keeping these smooth and round, because that's what they are. Okay, now let's go ahead and take a look at number 3. Here we have the y squared. And so now we can rewrite this as y squared is equal to -12x. So we know that we have an axis of symmetry is going to be the x-axis. I'll go ahead and write that below that. And the equation of the x-axis is y equal to 0. Okay, and since we have y squared equals -12x, we know that y squared is equal to 4px. So 4p is equal to -12, and p is equal to -3. So here, p is less than 0. So when our y is squared and our p is less than 0, we are going to be opening to the left. Okay, so will look like that. So now we can talk about our directrix. And our directrix is x equal to the opposite of p. And this time it's going to be x equal to 3. I think I put the directrix equal to y equals to the opposite of p. Okay. So, and then of course here we have 0p. I think I've written that on the other ones, but just wanted to make sure that you knew where those came from. Okay. So the directrix is x equal to 3, and that's x equal to the opposite of p. And now we can go ahead and talk about our focal diameter. And that is equal to the opposite. Let's just go ahead and move that over. That's equal to the absolute value of negative 12, and that's equal to 12. So now our endpoints are going to be at negative 3, 6 and negative 3, negative 6. So we have our center, of course, is at the origin. So we'll go ahead and put that here. And then we have negative 3. Right here. And so we can draw our smooth parabola that opens to the left. And as you can see, we have our vertex, which is at the center. I should probably put that as vertex, is at the origin. And then we have our focus is P0. So let's see if I can do something here. And here we have P0, so that's negative 3, 0. So I hope that that helps. Okay, so we can go ahead and put that focus as negative 3, 0. Okay. So what if we have a parabola with a vertex that's not at the origin? The equations look pretty similar. As you can see, now we have x minus h and y minus k in place of x and y, respectively. Our focus, we will be adding p to the y coordinate when we have a vertical axis of symmetry. And when we have a horizontal axis of symmetry, we will be adding p to the x coordinate of the vertex to come up with the focus. Our directrix, k minus p, is what y is equal to, and then x is equal to h minus p. As you can see here, we have a parabola opening up or down if the x is squared. So the x minus h is squared. And if the y minus k is squared, we will be opening left or right. Okay, so we're going to go ahead and take a look at our example and just try to work through some of that. And you can pause the video if you'd like to read through some of that some more. So we're asked to graph this parabola, y minus 5 squared equals 8 times x plus 2. As you can see, our vertex is negative 2, 5. And I think it's worth just going ahead and putting that on the graph. There's our vertex. Okay, so we know that you can see that we have 4p equal to 8. And remember, we used to have 4p with our y squared term. We would have 4px equals the y squared. So this 8 is what's going to be equal to 4p. Okay, so now we have p is equal to 2. So we know since the y is squared, we know we have a horizontal axis of symmetry. And we can now see, since p is positive, we will open to the right. Okay, so now let's go ahead and come up with our focus. We already have our vertex. So our focus is going to be that x coordinate of the vertex. And now we're going to add p and then keep our y coordinate of the vertex. And so that's going to be 0, 5. And there is our focus. And now we can take a look at our directrix. And as you can see, that directrix is going to be x equals h minus p. So now we will have -2 minus 2, and that's going to be -4. Is our directrix. Our focal, and we can go ahead and dash that in. Okay, and now we'll find our focal diameter. And that focal diameter is the absolute value of 4p. And that's the absolute value of 4 times 2, and that's 8. So the focal diameter is 8. Now let's look at our endpoints. So our endpoints are 0, and now we're going to add 4 to our y coordinate. And then we have 5 minus 4. And we'll subtract that. So that's h minus. So we can go ahead and place those points. So we have 0, 1, and 0, 9. And we can go ahead and draw our parabola. Okay, so now let's go ahead and look at number 5. Write the equation of the parabola in standard form. So the first thing we need to do is go ahead and isolate that y squared term. So whichever term is squared, we will isolate with the variable that is with that. So we want to isolate the y squared, since the y is squared, the y squared term, and we need to also take that y term with it. Then we will go ahead and move the 16x term to the other side and that 71. We'll go ahead and factor that 4 out, leaving a blank. And then, of course, half of 3, so we could go ahead and take 3, divide it by 2, and square it. So we have 9/4 that we will be adding. However, we are not just adding 9/4, we are adding 9. Okay, so now we could go ahead and have 4, and now we'll complete our square. Y plus 3/2 all squared is equal to, and we could go ahead and see right here that this is equal to negative 16x plus 80. And I want to go ahead and factor a negative 16 out of that, and I'll have x minus 5. So now I just have to divide both sides by 4, and I will have negative 4 times x minus 5. So we can move a few of these down just a touch, and maybe, whoops, and maybe this one down just a little bit. Okay, now let's take a look at number 6. Determine the standard form of an equation of the parabola with focus -5, 8, and directrix y equal to 6. So if you can see here, let's go ahead and set up a little graph here. And we see that the focus is -5, 8. So you can see the focus here, and then we have the directrix as y equal to 6. So remember that our directrix is y equal to k minus p. So we could actually go ahead and this is y equal to 6. And of course, this is 8 here, and that's 6. And so keep in mind that when we have the directrix, y equal to 6, this is y equal to k minus p. So now we know that p must be equal to 1, since we have k equal to -5. So we have 1 and 1 here. So we have a distance of 1 here and 1 here. So we know right here is going to be our vertex, is going to be -5, 7, since we have a distance of 1 here and 1 here. It's kind of hard to see. Okay, and so since we have p equal to 1, we now know that since we have a directrix y equals, we know the vertical axis of symmetry, and we also know that our equation is x minus h squared equals 4p times y minus k. So we do know that We are opening up since P is 1. And we can go ahead and fill in this next one. So we have x plus 5 all squared is equal to 4 because 4 times 1 is 4. I can rewrite that. And then we have y minus 7. Okay. And then I can just go ahead and sketch this like that. Okay, use parabolas in applications. And so our last problem today is something that's very famous, a very famous logo, and it actually consists of 2 golden parabolas. If a coordinate grid is placed over the logo, you can see it right here, the coordinate grid, we discover that each parabola intersects the axis, x-axis, 4 units from the center, and the height of each parabola is exactly 8 units when measured 2 units from the origin. Find the equation of each parabola in standard form. So the first thing I want to do is place some points here. We know that each parabola is exactly 8 units high when we're measured 2 units from the origin. So we have 2, 8, and we have negative 2, 8. And so those are going to be the vertex for each parabola. So the first thing I want you to know is that since these are opening down, and let's start with the parabola on the right. So the right parabola it opens down. So we know that if it opens down, we know that the x is squared. And so we can go ahead and write our vertex. I'll go ahead and write this equation. So we know using that vertex, we have x minus 2 all squared. We have our 4p, and we have y minus 8. So looking at this point that we are given, we do have a point on the parabola that we're sure of is 0, 0. So plugging 0 in, we have 0 minus 2 squared equals 4p, 0 minus 8. So we end up with 4 equals 4p times negative 8, or 4 equals negative 32p, and p is equal to negative 1/8. This confirms, since p is negative, this does open down. And we'll just put confirmed because we knew that already by the graph. Okay, so now we can come here and say that x minus 2 squared is equal to 4 times negative 1/8 times y minus 8. And so we have x minus 2 squared is equal to negative 1/2 y minus 8. So this is the parabola on the right. For the parabola on the left, all we have to do is change this x-coordinate of the parabola. The x-coordinate of the vertex. Okay, so here's the x-coordinate of this parabola on the right, the vertex of the parabola on the right, and we have the x-coordinate of the vertex. The x-coordinate of the parabola that's on the left. Whoops. And this concludes this section.